In this video the following concepts are studied. Determine the velocity and time from the graph. Investigation of tangent line slope properties. Determine the acceleration with the help of a graph slope. Determine the direction of movement, etc.
In part 11 we learned important information about the position time graph. Please note that this video may look like part 11, but it is completely different. Because this topic presents the velocity time graph, and should not be confused with position time. Because the methods and results of these two graphs are different from each other. We said before, that we have three main graphs. We examined the position time graph in parts 11, 12, and 13. Now we want to examine the properties of the velocity time graph. Tip 1. By drawing horizontal lines in the velocity time graph, the velocity of the object can be determined, and by drawing vertical lines, time can be obtained. Consider this point for example. This point indicates that the moving object moves at a velocity of 5 meters per second at moment 3. At moment 5 we cannot say exactly, but we can say that it moves at a velocity of about 2.5 meters per second. In the same way, we say that the velocity of an object at the moment 9 is 6 meters per second. The initial moment is an important moment. In fact, moment 0 represents the initial condition. Here we see the velocity of the object at moment 0 is 1 meter per second. This velocity is called the initial velocity. Now let's look at the whole graph. At first, the object was moving at a velocity of 1 meter per second. Its velocity increases, and at moment 3, it reaches a velocity of 5 meters per second. It then slows down, until it reaches 1.5 meters per second at 6.5. Increases its velocity again. At moment 9, its velocity reaches 6 meters per second. Note that at no point, the velocity of the object is negative, only increasing and decreasing. Here is a fundamental difference between the place-time graph in part 11.
Tip 2. If we have a velocity time graph, the acceleration of a moving object is equal to the slope of the tangent line to the graph. Remember, in the position time graph, the slope of the tangent line indicated velocity. So make no mistake. For example, consider the initial moment, draw a tangent line to the graph. The slope of this line is positive. We understand that the acceleration of object is positive, and the velocity of the object increases. At this point, that is moment 3. The slope of the tangent line is 0. That is, at this moment acceleration of object is 0. And the velocity of the object remains constant for a moment. At this point, that is moment 5. The tangent line is downward, and its slope is negative, thus the acceleration of the object is negative. Generally, in velocity time graph, if the slope of the tangent line is positive, the acceleration of the object is also positive, and the velocity of the object increases. If the slope of the tangent line is negative, the acceleration of the object is also negative, and the velocity of the object decreases.
In the previous example, the velocity was reduced or increased. But it did not change the sign. In the following example the direction of object changes. Note, if the velocity of a moving object is 0 and the sign of velocity changes, the direction of movement is changed. Note that two conditions are necessary for the direction of the body to change. 1. The velocity of the object becomes 0. 2. Change the velocity sign. Example. The velocity time graph of a moving object is as follows. Specify its direction. And at what moments the direction of object has changed? Answer. The initial velocity of the object is -2 meters per second, that is, it moves in the opposite direction of the coordinate axis. The object slows down. At moment 1 the velocity of the object becomes 0. After that, its velocity becomes positive, that is, it moves in the direction of the coordinate axis, and its velocity increases, then its velocity decreases until at the moment 5, the velocity of the moving object becomes 0. It means, object stops for a moment, but then velocity becomes positive again, that is, it moves in the same direction as before. Therefore, in moment 5, although the velocity is 0, the direction of movement does not change. Generally, in the velocity time graph, if the curve is above the time axis, the velocity is positive, and if it is below the time axis, the velocity is negative. In the next section, to see the calculation method, we will calculate the acceleration of an object from a graph.